Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Tetriscages by LCY. I think LCY? Yeah, LCY. And here are the rules. We have normal Sudoku rules apply, which means put the digits 1 through 9 in every row, column, and 3 by 3 box. We also have killer cages, where digits in a cage sum to the total given in the cage's upper left corner, and digits do not repeat in a cage. So for example, you didn't actually need that rule set because of the next rule that you have. But anyways, these 4 digits must add up to 14. These 4 digits must add up to 11. These 4 must add up to 17, etc., etc. So a valid example here could be something like 2, 3, 1, and 8. And that adds up to 14. There are no repeats in the cage. But if you'll notice, it says in extra regions, digits in the same type of tetrominoes do not repeat. So this is the same as this tetromino, right? So these cannot have repeats within this tetromino. But you also can't have repeats within the killer cages. You could not have repeats within this tetromino and this tetromino, same with this tetromino and this tetromino, etc., etc. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, one I first saw is this 4-cell cage adding up to 11. There's only one distinct set which adds with unique digits that adds up to 11 of 4 digits. It's 1, 2, 3, and 5. So this is 1, 2, 3, and 5. And this added up with the 27 would have to not have a 5. Therefore, it has to be 4, 7, 8, and 9. To add up to 20, actually 4, 6, 8, and 9 would add up to 27, right? You can't have a 5. You're missing essentially, this is 45 minus 27 plus 11, which is 38. So 45, you're missing a 7, right? So you can do that for all the tetrominoes because there should be, except for the square. The square is by itself. But every other tetromino essentially has the digits 1 through 9, except they're missing 1 digit. So these T-like tetrominoes is missing a 5 because it's 45 minus 14 and minus 26, which is 40. So it's 45 minus 40 is 5. So this is missing a 5 here. So this has to be 1, 2, 3, 4, 6, 7, 8, 9. 1 cannot be in this 26 tetromino. And 9 cannot be in this 14 tetromino. Because you need at least 2, 7, 8, 9 to add up to 26 here. The 16 and the 28 tetrominoes add up to 44. And these are the same tetromino, so we're missing a 1. So this cannot be 1 here. It could be 2, 3, 4, and 7. 2, 3, 5, and 6. This 28 can only be 4 through 9. So this is 2 through 7. This is 4 through 9. For the orange tetrominoes, the L's, they add up to 13 plus 25. Okay, also in column, okay, so this 1, 2, 3, 5, 4, 6, 8, 9 all see this cell right there. So this must be a 7 here. because it cannot contain any of the digits in these tetrominoes and their unique digits here. And it has to be 4, 6, 8, 9 to add up to 27 and 1, 2, 3, 5 to add up to 11. Therefore, the rest of column 1 must be 4, 6, 8, and 9. This is 4, 6, 8, and 9. These, I don't remember what they're called. S tetrominoes. Yeah, these S tetrominoes, it adds up to 17 plus 19, which is 36. So they're missing a 9. So this cannot be 9 here. This can't be 7 because of this 7. This cannot, well, we don't know actually. So this cannot contain a 7. So the 7 has to be one of these. So we have 7 plus 3 other digits adding up to 12. Adding up to 12. Yeah. So this is 7 here because this is fully within this box. So the 7 has to be here. It cannot contain a 9 because of the way that these two add up and that they're unique within the cages. So it cannot be 129. It could be 138. Cannot be 147, obviously. So 138 is possible. No 147. 156 is possible. 2. Starting with 2, we could have cannot have 237 because we already have a 7 guaranteed here. Could be 246. Okay, so this is still pretty broad. And this is basically everything. All the digits. Without a 9. So 9 cannot be here. Cannot be in the 17. So 9 has to be one of these two digits here. Which means... and we do need a 9 in actually these... in this set because 9 cannot be here. And it has to be one of the digits in this T tetromino. And one of these must be a 9. So that means 9 has to be one of these 3, and it has to be one of these 3. So 9 cannot be here in box 8. 9 has to be here in box 7. So in box 4, where is the 9? It has to be here. So this is 9, which means 9 has to be one of those 3. That's fine. In these... I don't know. Is this N? These N tetrominoes, or Z tetrominoes, we have 23 plus 15, which is 38? Yes, so it's missing a 7 here also. So this cannot contain a 7. So, and in this, these are also 13 plus 25, which adds up to 38, which is missing a 7. So none of these can be 7s. That's interesting. So none of these can contain a 7. So there's no 7 here. There's no 7 here. Because they all add up to 38 for those two. This is also, yeah, adds up to 38, which makes sense. 36, so you're missing a 9. And this is 44, so I'm missing a 1. This could be 1, 2, 3, and 9, possibly. So this doesn't guarantee. Okay, so this has to have a 1, right? It's 1 if we don't have a 1, the most that 4 digits uniquely can add up to is 14, which is 2, 3, 4, and 5. And so this has to have a 1. Again, it cannot contain a 7. So that means it cannot be 1, 2, 3, 7. So this is 1, 2, 3, 4, 5, 6. This must contain an 8 and a 9 here then. Right? Because it cannot have 7. And this can't contain 8 and 9. So since this is 8 and 9, the remaining 2 digits must add up to 25 minus 17, which is 8. And you can't have 7, obviously, so 1 7 is removed. It's 2, 6, or 3, 5. So we know 1 and 4 are both here. That means they see these 2 digits. This cannot have 1 and 4 here. So this is 2, 3, 5, 6, 7, 8, 9. Where is the 1 in row 7? It has to be one of these 3 digits. Oh, actually, and we know this is 1 through 5 because the remaining digits in row 9 have to be not 4 through 4, 6, 8, 9. So it has to be 1, 2, 3, 5. 9, we don't know which ones. So this cannot be a 9 here. Therefore, 9 has to be one of these 2 here. And we know a 9 has to be one of these 4 here. So in boxes 6 and 9, we cannot have a 9 because we need 1 9 here and 1 9 here. This then cannot be a 9 because the 9 in both boxes are removed. So this must be 1 and 4, and we have a 2 6 pair or a 3 5 pair here. We're not sure which. So this has to have 2 digits from 1, 2, 3, and 5. If we had 1, 2 here, I guess it could be 7, 8 here. That is possible. This can't be 1 because one of the 1s has to be here. So this is 2, 3, or 5. 1 has to be one of these 3. Which means, where is the 1 in box 8? Can't be here, can't be here, can't be here, so it must be here. So this is 1. This can only contain 1 out of 2 or 3. At most. This can only contain 1 out of 2 or 3 at most. So this must contain 2 or 3, and this also must contain 2 or 3. So the 2 or 3, because there's no other place for 2 or 3 in box 8. So the 2 or 3 has to be here, the 2 or 3 has to be here. If this is 2, it's with 7, 8, or 9. If it's with 3, it's with 6, 8, and 9. So this is either 7, 8, 9, or 6, 8, 9 here. So this cannot contain a 4. We know we have a guaranteed 8. This is a guaranteed 8 also. So that eliminates 8 from the rest of box 7 and 8 because we have to have an 8 here, we have to have an 8 here. This can't be 8 here and is guaranteed to have 1 and 4 here. So since 8 is here and 8's here, we have both 8's accounted for in box 7 and 8, which eliminates 8 in the rest of the boxes. So this can't be 8. This can't be 8. We know we need an 8 and a 9 in this 25 cage. So this has to be 8 and 9 as a pair. Similarly, we know we need an 8 and 9 in this cage, right? Because this can't be, this is at most 2, 3, 4, and 7 as the largest digit. So 8 and 9 both have to be here. So we know we need an 8, 9 here. We need an 8, 9 here. In box 6 and 9, we have all the 8s and 9s covered in this column and this column. So this cannot have an 8 and 9 in the rest of box boxes 6 and 9. So this cannot be 8 or 9. It can't be 1. This is 2 through 7 then here. So this cannot be 1 and 2 specifically. This is 2 or 3. This is 2 or 3. This then must be 2 or 3. And this must be 2 or 3 also. This cannot contain an 8. It cannot contain a 7. And it adds up to 17. Can it ever contain a 1? Without 7, and it doesn't have a 9. So there's no 9, no 8, no 7 here. If you had a 1 here, it would be 1, 4, 5, and 6 at most, which adds up to 16. So 1 cannot be here. This must be a 1 here, which means neither of these can be 1. This becomes a 2, 3, 5 triplet, which eliminates 2 and 3 in the rest of this box, and 5, but we don't have a 5 here. Therefore, and we know this must contain 1, 2, or 3, so the 2 or 3 has to be here. So this is a 2 or 3. This is 1, 4 with 2, 7, or 1, 4 with 3, 6. We're not sure which. This is 2 or 3. Where is the 4 in box 8? It must be here, so this cannot be 4 here, which means we need a 4 in one of these. So this has to have a 4. This is 8 and 9. That eliminates 8 and 9 cannot be here because this requires an 8 and 9. This requires an 8 and 9. And that eliminates 8 and 9 in the rest of those boxes. Therefore, 8 and 9 must be here, which means this can't be 8 or 9 here. This is also, actually, this has to be a 8-9 pair here. Because if this is 8, the 8 has to be here. But then the 9 has to be here, which means 9 can't be here, so 9 has to be here. So this is an 8-9 pair here. Therefore, this is an 8-9 pair here. And this must be, it cannot be 1 or 4. This is 6 or 7. To be with this corresponding digit here. This has a 4. We have 3 digits remaining, adding up to 17. So we need a 1 here, because there's no 1 remaining in this S shape. So this needs a 1. You can't... You could have... Okay. You can't have an 8 here. You need an 8 here. So this has to be an 8 here, which means this can't be 8. This has to be 1 and 8, with remaining digits then must be correspondingly... Well, you can't have 4, 6, because the 4 has to be here. So 1 and 8 adds up to 9. 19 minus 9 is 10, so the 2 remaining digits must add up to 10, right? So it can't be 4 and 6, because this requires a 4. And it can't be 5 here, so this must be... It can't be 2, 8, because we already guaranteed the 8, so this must be 1, 3, and 7 here, which eliminates 1, 3, and 7 in the rest of this. This must be 2, 4, 5, and 6 here. So it's 2, 4, 5, 6, which means this can't be 2 or 5. This has to be a 3. This 3 eliminates 3 in the rest of row 9. So it's a 1, 2, 5 triplet, which eliminates 1, 2, 5 from the rest of box 9. So this can't be 2 or 5. This can't be 5. We know this cannot be 1 and 2, because that requires 7 and 8 to be here, and 8, this 8-9 pair having to be in both of these cages eliminates 8 from being there. So this has to have a 5. It's either 1, 5 or 2, 5. Okay. This is 4. This has to be 6, so this cannot be 6. So this can't be 6. So this has to be a 3, 5 pair, which eliminates 3 from the rest of this box. So this is 2 with 7, 8, and 9. This 3, 5 pair eliminates 3 and 5 in the rest of row 7. Therefore, this is a 2, 4, 6 triplet, which eliminates 2, 4, 6 in the rest of box 7. So this is a 5. This is 3 and 5. This cannot be 3. This is a 1, 3, 7 triplet. The rest of box 1 has to be, cannot be 8 or 9, cannot be 1, 3, 7. So it's 2, 4, 5, and 6. 5 cannot be here. Where is the 5 in column 3? It has to be here. So this is 5. And 2 has to be one of these two digits here. So this cannot be 2 here, which forces this to be a 2 here. Therefore, this can't be 2 here. 2 is one of these two. Five cannot be any of these digits here. We know there's a 2 here. We know there's a 2 here. That eliminates 2 in the rest of rows 1 and 2. Either this is 2, 3, 4, 7, or 2, 3, 5, 6. So this can never be 6 here because this would force this to be 5. So 2 has to be one of these 4. 2 has to be one of these 2. Can this ever, I guess it could, okay, so 1 and 5 add up to 6, which means this adds up to 12, which is not possible because we don't have 3, 9, we don't have 4, 8, and we don't have 5, 7 here as these digits. So this cannot be 1, 5. It's a 2, 5 pair, which forces this to be 1. This cannot be 1 then. This is 2 and 5, which adds up to 7. 18 minus 7 is 11, so it has to be 4 and 7 here. This is a 4, 7 pair, which eliminates 4 and 7 in the rest of the box and the row. This 4, 7 pair eliminates 4 here, so that's 6, which makes this 4. These can't be 4. These can't be 6. This also eliminates 7 here. This becomes a 2, 8, and 9 triplet, which eliminates 2, 8, and 9 the rest of the row. This can't be 4, 7, or 6, so this is 3. These can't be 4, 7. It becomes 6, 8, and 9 here, which eliminates 6, 8, and 9 in the rest of the row, so this is a 7 here. This 8 eliminates 8 here, and 8 here. This has to be 4, because this can't be 4 here. This can't be 6 either, because of this 2, 6 pair in the column. This is 2, so this can't be 2. This has to be 3, which means this can't be 3. This is 7, so these can't be 7, so this is 1 here, which makes this 7. This has to be a 1, a 4, 6 pair, which eliminates 4 and 6. This 7 eliminates 7 here. This 1 eliminates 1 here, so this is 7. The 3 cannot be here, and we know this doesn't have a 7. So where is the 7 actually in box 5? Can't be here, it must be here. So this is 7. This can't be 7 anymore, so this has to be a 7. Well, we don't know, actually. This can't be 7, and this can't be 7. This could technically be 7, but we have a 6 guaranteed here. So this cannot be 1, 4 with 2, 6, right? 1, 4 is 5. 13 minus 5 is 8. The 6 has to be here, so this can't be 6. So it can't be 2 and 6, which means this is the 1, 3, 4, 5 quadruplet. That eliminates 3 and 5 here, because they all see these cells. Wait, that doesn't work. It's 1, 2. I don't know why I have 4 here. This is not 4. This is 6. So it can't be 1, 2, 3, 6. No, wait. 1, 2, 4, 6. Oh, I'm thinking of the wrong one. This is 6 here, so this can't be 6. Apologies for that. Oh, this is 3, 5 anyway, so this can't be 3, 5. So this is 1, 2, 4, 6. Okay, which eliminates 2 and 6 in the rest of these cells because they all see 1, 2, 4, and 6. This is 6 here, which means this can't be 6. This has to not contain a 6. So it cannot be 2, 3, 5, and 6 adding up to 8, 16. It must be 2, 3, 4, 7. Which eliminates 4 and 7 here. Therefore, this is a 5, which means eliminates 5 from the rest of this box here. So this can't be 5. This is 3. This is 7. 5 is here. 7's here. 7's here. This eliminates 7 here. So that's 4 and 7. None of these could be 4. Where is the 4 in this box? We need a 4. It has to be here. 7 cannot be either of these two cells because of this 7. So 7 has to be one of these two. 7's here. This can't be 7 because of the 7 in the column. So this has to be 7 here. That means 7 can't be here, 7 can't be here, 7 can't be here, so 7 has to be here. Actually, we have 8 7s, so that was also another way of putting it. This is 4. In column 9, where is the 2? Can't be any of these because they're already limited, so it must be one of these two. So these can't be 2, which means this is a 3, 4 pair, which eliminates 3 and 4 in the rest of the box, so this is 2. That 2 eliminates 2 here, so this is 6, this is 2. These 2's eliminate 2 in the rest of rows 1 and 2, so this can't be 2, this has to be a 2, which means this can't be 2. This has to be a 2, which eliminates 2 here. 2 cannot be in this cage, and it can't be here, so 2 has to be in this cage. It cannot have a 3. 3 has to be one of these two digits, because again, these add up to 38, which is missing just a 7. So 3 has to be here, which means this can't be 3. This is 5, which makes that a 3. This is missing 3, but it has to have a 2. Okay, so we know the 2's here. 3 eliminates 3 here, so this must be a 2, 5 pair, which eliminates 2 and 5 here, so this must be 3. This 5, 8, 9 triplet eliminates 5, 8, 9 in the rest of box 6, so this must be a 1, 6 pair here. That leaves this as a 2, 5 pair, because of the 1, 6 in the 3, 4, and the 8, 9 pairs here. So, and this can't be 2 because of the 2 in the box. So this is 5, this is 2, this is 5. This can't be 6 because of the 1, 6 pair in the column. So this must be the 6 here. We are missing then an 8 or a 9 here. So this is 8, 9. This is 8, 9 because of the combinations. This 8, 9, 8, 9 pair eliminates 8 and 9 in the rest of row 1. This can't be 8 or 9, so this is 4, which makes this 9, which makes that 8. That 4 eliminates 4 here, so it's just 3 and 4, which makes this 1. So this can't be 1 either here. So this has to have a 1 in this cage, so 1 must be here, which makes this 6, which makes that 1. This 6 eliminates 6 here, it's 4 and 6. This has to have a 2. 2 cannot be here, but it could be either of these spots. So we have 1 and 2 here. That means the other two digits must add up to 12. So, but it cannot be 3, 9, cannot be 5, 7. It must be 4, 8. So this must be 1, 2, 4, and 8. Obviously, this can't be 2. This can't be 4. That means the other remaining digits here are 3, 5, 6, and 9. To add up to 23. 3 obviously can't be either of these. This 8 eliminates 8 here, so this is 2. This can't be 2. This can't be 2, so this is 9. This eliminates 9 here. 5 and 6 add up to 11. 3 and 9 add up to 12. And 12 plus 11 is 23, so this works. This can't be, this 9 eliminates 9 here, so this is 8. That makes this a 2. This 8 eliminates 8 here, so that's 9. These can't be 9 here. This 5, 6 pair eliminates 6 in the column, so this is a 4. These can't be 4. This has to be, well, this 4, 8 pair eliminates 8 here, so this is 9, which makes that 8. This 9 eliminates 9 here, so this is a 5, 8 pair, but the 8 is eliminated by the 4, 8 pair, so this is 5, this is 8. That 8 eliminates 8 here, so it's 9 and 8. This 2 eliminates 2 here, it's 5 and 2. This 8 eliminates 8 here, so this is 9. This is 8. This is 9. This 5 eliminates 5 here, so this is 6. This is 5. This 6 eliminates 6 here. It's 1 and 6. 1 eliminates 1 here. It's 3 and 1. That eliminates 3 here. It's 9 and 3. And the rest we get by Sudoku. We have remaining here is 4, which can't be here. So this is 4 and 5. This 4 eliminates 4 here, so it's 8 and 4. The 8 eliminates 8 here. 6 and 8. Oops. I don't know, I skipped that. That's 8. This is then becomes a 6, and this is a 9. And that's how you solve it. Pretty cool, actually. I like the theme of Tetris with the cages, and the rule set of the extra region, where you can't have repeats in the extra regions, was pretty clever, actually. Very clever. I like this. This was a very cool puzzle. Nice job, Elsie. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.